So this is just a quick summary of nodal analysis. So nodal analysis is a method that combines many different equations to better analyze complex circuits. The circuits often contain multiple voltage sources, as seen here, and elements in both series and parallel, so it would be difficult to find currents flowing through these resistors using other methods. So using nodal analysis, you combine Ohm's law and Kirchhoff's current law at a node like this one here, and using that you can find currents. So in this example, we want to find current flowing through each resistor and the voltage associated with it, and we'll do that by analyzing this node here. So the first thing to do is to assume current direction. It doesn't matter which way you assume. If you get a negative answer, you just know it was the other way. And we've defined the point being VA. So the next step is to create a zero node here. So this node we assume to have zero voltage, and you want to connect this to a node that is connected to both power sources like this, as it makes the equations a whole lot easier. And you can see that 10 volts is flowing through this resistor and 6 volt is flowing through this resistor. So the next step is to apply KCL at the node VA, and we assume that if the current is flowing into the node, it is negative, and it's flowing out of the node, it's positive. So you get the equation I3 minus I1 minus I2 equals 0. And using Ohm's law, you can find I equals V over R. And to find V, you take the 6 volts flowing into the resistor, and you minus the VA volts flowing out. And for I3, you have VA volts flowing in, and you have 0 volts flowing out. So that's how you get these top values here, the voltage values, and you just divide by the value of the resistor. And then we want to remove the denominator, so you multiply each fraction by the lowest common denominator, which is 6 in this case, and then expanding out and solving for VA, you get VA is equal to 3.6 volts. The next step, you want to find the voltage, so you do what we did last time, and you take 6 volts minus the VA, which we now know to be 3.6, and you get 2.4 for V1, and if you do that for all the other elements, you can find the voltage across them. The last step is to find the currents, which is what we wanted. So you take the voltage you found in the last step and you just divide it by the resistance value of the resistor, and you can get all the currents here. So nodal analysis will give you nice values for the voltage and currents through different elements in a circuit, and it is pretty easy to do, as you just saw. And using other methods, this would be a whole lot harder. Thank you for watching.